Terrific. I feel I'm ready for my L1 exam now at the end of that. That's good. Thanks for the setup. Let's go on now to U.S. governance of biotechnology. We have Dr. Megan Palmer with us from Stanford University.
Thank you very much. It's a real honor to be here, and especially to speak in this session. I would thank the committee for actually describing it as scales of governance. And I'm going to take a little bit of a liberal approach to that topic, and I also thank my other panel member for covering the more formal rules and regulations, both internationally and a little bit domestically, as I will not speak as much about the formal rules, but rather what happens when rules hit the ground and the gaps in implementation. So this is the statement, part of the statement of task that I was given. The only point here is that this is a lot to cover, and I don't envy the task of this committee. So I'll distill it for you, essentially being asked regarding gene drives, and not only gene drives, but its precedents for emerging biotechnology. What are the current oversight mechanisms? What are the current governance mechanisms? And are they adequate now and in the future? I will give some preliminary thoughts on this. There's quite a lot to do. But my take home on the topic of scales of governance is really that we need to think about not just biotechnologies, but emerging technologies are really changing who has the power and the capacity to govern. And this, again, as the wider scope of who has the capacity to shape behaviors. I like this comic quite a bit. It's from XKCD, and it's an attempt to map the internet. And the reason I like it is because it asks, who are controlling the norms and the activities on the internet? And it has this is quite a few years old now, but I wonder how many of you are checking Facebook at this very moment, or using that as a communication platform. Really asking what types of entities are shaping norms and behaviors across this rapidly emerging domain. And so we also need to ask, what are the types of organizations in biotechnology that are shaping on domestic and international, local scales, the behaviors, the norms, the attitudes that really translate policy into practice. And this is the example of the iGEM competition, which I'll speak a little bit about later. More particularly, the take-homes on scales of governance are, I want to highlight this in particular. I think we have really sparse and poor data on the performance of current governance systems, not only in the life sciences, but especially in the life sciences. Preliminary evidence and my own observations suggest that our current governance systems are inadequate to deal with emerging biotechnologies, including gene drives, but probably not for the reasons you think. There's issues, I think, in this case, the issues of timing, scale, and complexity are not qualitatively different, but the extent to which they differ with a technology like gene drives poses qualitative differences in the types of governance structures that might be necessary to deal with them, and particularly in how we deal with uncertainties and ambiguities in the current structures. The stresses are on authority, expertise, and coordination, and these are really ones of management. And last, gaps in really connecting across the scales that we'll talk about today. And lastly, gaps exist both in the design of systems of governance and oversight, as well as in their implementation. The key point here that practice moves faster than policy. We need to understand and leverage network governance. This is the particular term I use to describe the middle ground between what Bruce Jennings this morning described as two different modes of governance, and that there are key gaps in leadership, accounting, and communication. So I'm going to attempt to go through some justification for these claims and observations, so bear with me. So just first of all, so you know who I am, my background is actually as a bioengineer, as a control systems engineer at some of the places where this technology is being developed. For the last 4.5 years, I worked at a multi-university research consortium in synthetic biology called SynBERC that spreads across many labs across the United States, working to develop the forefront in genetic engineering technologies, and a number of other organizations that have served as experimental venues for adapting governance systems. I now am a senior research scholar at Stanford at the Center for International Security and Cooperation, trying to backtrack some of the lessons learned from this in the architectures of governance structures for innovation, safety, and security. And I shorthand this as engineering biology at social scales. And my research questions really look at how do we manage risks involved in making biology easier to engineer, in particularly challenges of global distribution, exchanges between digital and physical domains, the unpredictability of advances, time compressions, limits on use of traditional tools, and importantly, we haven't talked as much here about the sensitivities in industry with respect to confidentiality and trade that are going to play an important role here. Really looking at how we can measure the performance of our oversight systems, the metrics we use, and trying to understand what structures are effective at governance, and designing better decision support tools. Around traditional questions of whether or not we're having fundamental differences in where we can impose stopgaps with materials, personnel, and information, and of course, many of these questions have been looked at before, but primarily qualitatively and in a very different environment. This is the example of the synthetic genomic study options for governance a number of years ago. I want to say a little bit about the scope, the task that I was given, which are national, and as was pointed out, these are really international issues. First of all, for context, the practice of biotechnology and the way in which we see gene drive technology emerging is really changing quite rapidly. So this is the iGEM competition, which you've heard about before, but only 15 years ago when I started grad school, and the idea of distributed tools and knowledge dissemination has rapidly expanded the number of practitioners and the number of places in which they're working. So this was last year at the iGEM competition with thousands of people convening to share their latest and greatest tools. This is a class in which I taught just a few weeks ago that in about a week we'll be teaching gene drives and synthetic ecosystems, first principles, to maker labs all over the world. This is the how to grow almost anything. This is a very different type of place in which we're trying to disseminate good practices. And of course, the most important thing is there's very different drivers that are shaping how policies and practices get adopted. A wide variety of different applications, and as Todd Kukin pointed out last time, shifting landscape of where funding is coming from, including a large amount of funding from the Department of Defense. I'm not going to go over all of the regulations and how they apply here, but just to say that there are many good references, and I've highlighted them here, that look over how current regulations, current oversight systems apply to gene drives and other related technologies in gene editing. They point to systems that have existed for a very long time, including the 1976 NIH guidelines and the coordinated framework. I did want to highlight that this outlines in what was attempted to be a very flexible governance structure the current authorities, and that what differs in the US versus a number of other regions is that we're looking at a case-by-case and product-by-product basis on applications and intended use, not on the technologies themselves, and that's really important to consider in this statement of work of this committee. And to cut to the chase, most of these reports say these authorities may be sufficient and are likely sufficient, but the infrastructure required to support and maintain their implementation are not. The number of cases that they're seeing, the novelty of the types of applications is causing complex competing and conflicting jurisdictional issues that are frustrating both regulators and practitioners alike. And when I say that the current regulatory framework may not be sufficient, it's not necessarily in the structure of the framework, but the number of instances in which they need to deal and the complexity of issues that they face and the resources and infrastructure to support them. This has been recognized. Later on this week, there'll be a public meeting about the review of the US biotechnology framework that has been highlighted. There's also, due to a number of instances, a review of the US biosafety and biosecurity regimes more broadly that's been kicked off through things like the safety stand-down and others last year. Again, the status of this is very difficult to decipher, but the intention is articulated. We're also at the same time seeing the review of risk frameworks for risky research in the labs. Again, related, not completely overlapping with the statement here, but one of the outputs of this process is also to deliver a conceptual framework for risk assessment. And even within the academies themselves, there are a number of parallel studies on gene editing technologies and biotechnology that are all supposed to be looking at conceptual frameworks for risk management of a number of emerging technologies with transboundary issues. And so I think for the committee, one of the things I would really like, and you are obviously asking yourselves, is what is the particular place of the recommendations of this committee within the overall context of reflections on how we treat emerging technologies, and especially in the life sciences. Despite the existing frameworks existing for a long time, and quite a lot of revision in the biotechnology frameworks, and instances and precedents of biotechnology going through the pipeline, what's interesting is we're still seeing reversion to many of the same tools by the scientific community to bring up concerns. And in fact, many of the same authors. So this is separated by 40 years statements in prominent scientific journals around the need to be concerned and the need for frameworks and tools in order to understand how advances in genetic technologies affect broader policy. And what this leads me to believe is that really this is due to both a gap in expertise and development of expertise from within scientific communities and within the government back to scientific communities about how to deal with complexity and governance and oversight. So I really like these slides. These are from the NSABB meeting just several weeks ago that try to put a map of who's in charge. It's really small font. It's really hard to even get a grasp of it. Even the folks that said this, like, oh, this is actually pretty easy to understand. But it points to there are overlapping issues at multiple scales. There have been some gaps that have been recognized. The White House issued new regulations for dual-use research of concern. At the institutional level, these went into effect, again, just a few weeks ago. And so I wanted to look at one particular assumption that I think is very important that underlies this policy as well as the policies on which it has been overlaid. That is looking at the institutional review boards as being a primary mechanism to identify concerns. And most importantly, the first trigger point in this being practitioners who are able to flag those concerns or were incentivized for those concerns. So I'm going to give just a few preliminary observations based on my own work and those of others on this assumption in particular that individual researchers can and will flag concerns. So I'm going to look at, in particular, these experimental venues that I discussed before that I've been embedded within for the last 4.5–5 years. And in particular, looking at questions of whether or not we can address compliance with institutional safety and address uncertainties and ambiguities that might lie beyond institutional reviews. Again, this first trigger point in this roadmap of our governance scheme. I'm also going to even look beyond that and ask, what are the considerations relevant to, in this case, a project design or results, and whether or not people identify resources required to address those uncertainties. I've looked at these across a number of organizations. As I mentioned, SINBRG is a multi-university research center LEAP is a fellowship program in responsible biotechnology development that I founded and helped manage. The iGEM competition, it's an undergraduate competition and now a wider competition in genetic engineering, and places like the Joint Genomic Institute at Lawrence Berkeley National Labs that have participated in their proposal management process. And so here we're looking at the effect to which we can identify issues within proposals. So I mentioned SynBERC is a 10-year effort within NSF. I led first with Drew Endy and then with Ken Oy, the policy and practices part of this research center. And it had a key role in being an intermediary between several different institutions and scientific and industrial advisory boards on being able to ask these types of questions embedded within reviews. So I'm using this as an instance of where we're looking at identifying and flagging concerns. I don't want to go into the details here, I don't have time, but here's just an example of where we can look at whether or not concerns are raised within the proposal process itself. These are a map of number of proposals and individual reviewer scores on whether or not they scored a concern. And from here, we can look at how these compare to automated or review or the director level decisions on whether or not proposals should go forward. Again, not to look into the details, but what you can tell from these types of analyses of systems is that neither the proposers nor the reviewers can robustly identify compliance and gaps in the current oversight system. And most importantly is from year to year, there were insufficient institutional mechanisms to promote learning from those gaps. Weak assessment, weak incentives, weak enforcement, and weak feedback. What's interesting is that when you ask people in a different context, can you tell me the concerns relevant to your project design and results and what resources you need? And here we asked on a number of issues, including safety and security, but also intellectual property, diffusion issues, ethics and justice issues, and translation and markets. Again, looking at proposals, again, I don't want you to look into the detail, but we can map the level in which concerns arise. And here, proposals could identify some but not all areas of concern and uncertainty. But the key issues are they were largely unaware of the mechanisms by which they should respond, and they felt they lacked the time, resources, and expertise and authority to proceed. And so our investments after that point really had to do with brokering capacities and connecting experts to the individuals that were flagging concerns. I want to give just a parallel example here of iGEM. iGEM has been in some ways a much better test bed to look at how oversight procedures work. Again, iGEM is located within the US as an international program. And here there's much more flexible capacity to look at organization, norms, and incentives. And again, the scales, international, leveraging local and national scale institutions and embedding on top of these different types of supplements to the existing regulatory and oversight processes. And looking at a number of variables, so what things can we add or supplement? We look at adding in institutional expert reviews as well as automated oversight procedures onto these. Look at adding in rewards and incentives. What are you required to participate? What do you need to not be kicked out of the competition? What do you need to win an award? As well as training in many of these different aspects. The key aspect that allows us to do all of these things is public disclosure on wikis of the initial intentions and the results along the entire scope of the research project that are looked over by volunteers and experts all across the world. This transparency allows us to capture issues and identify them early on, and allows them to be accessible to outside critique. As community building also leads to engagement and innovation, this is an instance where a German team from Bielefeld this year is handing in a report to the State Department official right across the street on their report on how iGEM can be used to promote dual-use awareness globally, as well as their local WMD coordinators discussing the FBI partnering with iGEM to open up channels of communication between law enforcement officials and the technology developers. So the data from here suggests In this instance, adding in these additional platforms allows for adaptive identification and assessment, stronger incentives, stronger enforcement, mechanisms of feedback, and open participation. But most importantly, this is all done by volunteers. And the resources in order to equip this type of review is very fragile and very vulnerable. I won't have time to go through this, but we're also looking at a number of platforms, how you can automate and scale these. I'm going to skip over this because I've run out of time, but I've also looked at a number of platforms where you can look at individuals going deeper on not just individual projects, but overall assessment of their career trajectories and the types of work they would like to do in biotechnology. This is this LEAP program that I mentioned. Kevin Esvelt, who I know has discussed his work here, was one of our fellows, really talking about what are instruments to enable not just himself, but others to enable biotechnology to be more in line with public interest. So lastly, I just want to end with some considerations for the committee. Coming back to my take-home points at the beginning. So the key thing I think this committee can recommend strongly is the need to enable better data on governance as we roll out the deployment and development of technology. And the need to enable platforms and frameworks that can allow the communication of results early on in the process and enable it to be assessed to outside critique. And importantly, look at the full spectrum of incentives that allow for disclosure of activities, including funding and regulation stages. Preliminary evidence suggests oversight systems are currently inadequate to deal with emerging biotechnologies. And here, we mean not in the types of regulations or the authorities, but really is what is the infrastructure that allows us to support those given authorities? What allows the quick and rapid dissemination, communication, identification of results, and tracking back to the issues after problems have arisen? Most importantly, how are we capturing learning and precedents? And gaps exist both in the design of systems of governance and oversight and in their implementation. Again, we need to develop systems for monitoring effects after deployment. I know there's been some comments on ecological research agendas, in particular understanding what are the effects of technologies that we have already deployed. We need to develop capacity in management. This is way too overlooked. We don't teach management, and this underlies the capacity for practitioners to be able to communicate and ask for the expertise that they need. And most importantly, need to legitimize the study and practice of risk governance, including comparative risk, with other high reliability or high risk fields. And lastly, we need to think about what is the foundation for network governance. This is long, but essentially scaling and evolving governance systems requires developing norms, tools, and incentives support transparency, accessibility, and accountability. Not just transparency, but the ability to comprehend that data, and acknowledgement of intentions, uncertainties, and failures. But the realities, and I hope the committee will put this in their report, is that this is expensive, right? It doesn't come for free. It requires leadership at many levels, and it requires better investment and management. So thank you very much.